doing 11.6a, talking about confidence intervals today. All right. So for 11.6a, we're doing confidence interval B. We're talking about hypothesis testing. Both of these are basically where we take a sample and we infer something about the population by analyzing that sample. So specifically for confidence intervals, the goal is to estimate something about the parameter to a specific degree of certainty. So when you guys say a confidence interval, it's going to sound something like, I'm 95% certain, or I'm 95% confident that the true average price of a prom dress is between $80 and $120. Something like that, right? So that's what a confidence interval sounds like, right? There's that degree of certainty, I'm 95% confident. That's the population parameter, the true average price of a prom dress is between some number and some number. That's the interval, okay? So that's generally what a confidence interval sounds like. So I'm gonna teach you guys how to create one, all right? So a couple of vocab things here. To find the confidence interval, we're gonna use what's called the maximum error of estimate, which the book labels E. How much you guys know I actually, from teaching stats, don't call it that and don't use that very well, okay? It doesn't really matter, but just so you know, it's also known as the margin of error, and I use ME. So not a big deal, but just in case you see it a little bit different, just know it's talking about the same thing, okay? All right, and then what we're gonna do is we're gonna take that margin of error and then create a confidence interval by finding the sample mean and adding and subtracting that margin of error. So your sample mean is going to be the center of your interval, and then you step down, margin of error, step up, margin of error, and there's your confidence interval, okay? And the formula you need to know is this one right here. So that is for the entire confidence interval. This part is the margin of error. That's your ME, your margin of error. And yeah, let me go ahead and label some of these variables for you. So this one right here is your sample mean. The Z is called your critical value. And that is determined by how much confidence you want to have in your interval. That 95%, or maybe you want it to be 99%, all right? So that's called your critical value. S stands for your sample standard deviation, and N is your sample size. All right, so 1, 2, 3, 4 variables in that formula. All right, and then you just plug it in, find your confidence. Okay, I want us to focus first on this Z, the critical value, and how to get that, all right? So here's a table of kind of the most common confidence levels and their respective Z values, all right? So to be 90% confident, that Z will be this number. If you want to be 95, you'll have a bigger Z value, right? The bigger the confidence interval, the more confident you would be in catching something, right? Think about like if you go fishing, right? If you have a small net, you're not gonna be super confident you're gonna catch a lot of fish, but you have a big net, more confident, right? So bigger the confidence, bigger the Z value, all right? Wider your confidence. So let me go ahead and show you guys how you get from here to here. Okay, how do you go from 90% to this number right here? So I'm going to show you with that 90. Let's draw a little picture here. All right, so I'm going to go ahead and draw myself a normal curve. All right, and I'm trying to show 90% confidence. So what I'm going to do with that 90% is I'm going to plop it right in the middle of that curve. So this is the center. I'm going to plot my 90% right in the middle. Okay. what the z value is these values, right? Positive and negative, this is 0, right? This is 0. Pause really quick, Olivia. All right, so then these are the values that will cut off the middle 90% here. Okay. So go to your calculators really quick and go to where you guys found normal CDF when we did lesson 11.5. And what do you see right below normal CDF? Inverse norm, yeah. So that's what we're gonna do. We're actually gonna go backwards. Because normal CDF, we gave it a value and it gave me the area. This time, you're gonna input the area and it's gonna give you the value that cuts it off on the normal distribution. All right, so you're gonna do inverse norm. And if you go ahead and click on inverse norm, the first thing it asks you is the area. All right, so the area that they're talking about is gonna be the left area. All right, so area to the left. So let's say I wanna find this z right here, this negative one. Let's find that area to the left. So I know what to input into my calculator. So any ideas how much this area would be if this is 90? 5%, exactly. How did you get 5%? Yeah, so divide. So you got 100% minus 90, so I know that's gonna be 10% total divided by 2 because it's symmetric. So that's 5% each left and tail. All right, so this is gonna be 5%. This is also 5%. All right. So if I wanna find this particular z, I'm gonna go ahead and put 0.05 and then leave the mean and standard deviation as 0 and 1. That's the standard normal distribution. So we're gonna leave that to get our z. And what do you guys see when it comes out? Negative? What? 1.645, and there it is. That's the number right here. Okay. Now, because it's symmetric and it's about 0, if this is negative 1.645, this is going to be positive 1.645, right? Makes sense. Does it matter if you do the positive or negative version? No, because when we do confidence intervals, what do we notice? Plus or minus. Yeah, so it doesn't matter. If z is positive or negative, you still get the same answer. Yeah. We typically just use the positive. All right, so once we know the negative, we know the positive. Okay. All right, any questions on that? All right, why don't you guys try it? See if you can pretend you don't know this answer and you're looking for it with 95%. See if you can get to the 1.96. Okay, I'll walk around and see if anybody needs help with their calculator. All right, go for it. All right, and I will say for these, I'm okay with you guys not showing the word inverse normals. All right, I'm okay because these are so common that people end up just like memorizing it inadvertently. Okay, so if you memorize it, go for it. Okay, if you use your calculator, go for it. So I'm okay if you don't show the word on how you found the z. Okay, all right, go for it. All right, so let's go ahead, now that we know how to find the z, let's go ahead and make the entire interval. So here's an example. It says a sample of 400 adults were asked the average time spent watching television each weeknight. The mean time was 68.4, standard deviation 20.9. Determine a 95% confidence interval for the population mean. All right, so first thing I would do is actually, I'm gonna label these. And I usually label these as I talk or as I read. I'm like, all right, that's my sample size. My sample mean, that's my x bar. Standard deviation, 20.9. And then the 95% tells me I'm going to have a z critical value of 1.960. All right, so I usually kind of just label as I'm reading. And then all you guys have to do is plug it into that formula. So plugging that all in to this formula, calculate, gets you this margin of error. And then when you add and subtract, you get your confidence interval. Okay? subtract first, low number first always, and then high number on the right. All right, so that is our confidence interval. So what does that tell us? Well, it tells us that we are 95% confident that this interval, 66.35 to 70.45 minutes, captures the true population average time adults spend watching TV each weekend. All right, so it's close to like a little over an hour. Checks out. Okay, questions on that? Let's go ahead and try it. Here we go. Number one, without any context, let's just do the calculations, make sure we're good here. So number one, how do we set this up? I want to find a 99% confidence interval. Tell me what that formula is going to look like. Jesse, give it a try. Perfect, nicely done, Jesse. Okay, go ahead and type it into your calculator. Let's just make sure nothing funky is happening in that process. All right, and then check with your neighbor, see if you guys have the same answer. Cool, here we go. All right, Sarah, what'd you get for the bottom number? Perfect. All right, and what did you get for the top number, Kevin? Oh, sorry, 79.9. Was there one more decimal? 4? Perfect. Awesome. Okay. Yeah, when it comes to the decimals, I would just say put enough that it shows that you did it right. Okay. So yeah, cool. Because of time, I want to make sure to give you guys back your test. Let's skip to number 4. All right. So number 4. Same thing. Let's go ahead. This time, Connor, can you set this one up for us?
21 plus or minus 1.96
Nice.
times 3 divided by the square root.
Perfect. All right. Go ahead and type that into your calculator. And hopefully, we're getting these numbers. I'll walk around quickly in case anybody is not. Yeah. Awesome, guys. Sweet. Looking good. So the last thing I want you guys to try now is with a word problem, because I'm going to tell you, most of the times it'll just give you it with the symbols and you just plug it into a formula. Most of the times it's a situation, so you need to know what those variables mean. So go ahead and try number 6. Whole thing where you have to determine what variable is what in that formula and then calculate. All right, go for it. All right. Good job, you guys. Go ahead and check your answers with mine up here. Final answer, in case I didn't check you, was that. All right. I think I saw most of you guys just, plugged in the correct variables in the right spot. 90% confidence, so that Z value was 1.645. If you simplified correctly, you got those two. Okay, awesome. Great job, you guys. We're going to go ahead and stop here because, again, I want to make sure we have enough time to give you back your Chapter 10 test. So let's take a break, and then we'll